Hello, I'm an old guy and I do maths, and this looks like a solid headache, doesn't it? Right, so our job is to simplify this expression, which has, I think, everything that could possibly scare someone who doesn't like index work. It's got fractions, it's got negative fractions, it's got various roots. So our first job here is to get everything to a point where we can actually work with it. And the first thing to recognize is that there is a commonality here. There's 81 is a product of threes. 27 is a product of threes. We've got 3 here. 243 is a product of threes. It's 81 times 3. So we can do something here. Right. So let's just get to work systematically and try and simplify this to the point where it's easy to work with, and then we can apply an index law to solve this in pretty short order. Okay, so 81 squared. Well, 81 is equal to 3 to the power of 4. So 81 squared is going to be 3 to the power of 4 squared. (27 to the power of negative 4 over 3). We're going to leave this as a negative for the moment. So 27 is 3 to the power of 3. So we're going to have 3 to the power of 3. So, sorry, we'll write 27 in here as it's represented there. So what that's going to equal is 3 to the power of 3 times negative 4 over 3. Okay, it's unappetizing, but it's still doable. The next thing I think is possibly the most perplexing. So we've got the third root of 3. Well, that is equal to 3 to the power of 1/3. So we're in business fairly quickly here, despite that being the possibly the most threatening. 243 is equal to 3 to the power of, I'll do this on my fingers, 3, 9, 27, 81, 243. It's 3 to the power of 5. And so we have 3 to the power of 5 times 4 over 5. Okay, what a mess. Okay, so let's get this rewritten. We have 3 to the power of 4 to the power of 2 times 3 to the power of 3 to the power of negative 4 over 3 times 3 to the power of 1/3. So far that looks the most appetizing. All over 3 to the power of 5 times 4 over 5. Wow. Okay. Right, let's get to work. So this is 3 to the power of 8. 4 times 2. This is going to be 3 to the power of 3 times that fraction, which is negative 12 over 3. Negative 12 over 3. Negative 12 over 3. That simplifies to negative 4. So that's 3 to the power of negative 4. We'll leave this as it is, 3 to the power of 1/3. And this thing down here, 3 to the power of 5 times 4 over 5. 5 times 4 is 20, so that is 20 divided by 5, so 20 over 5, which gives us, surprise, surprise, 4. Okay, so that is 3 to the power of 4. Great. Okay, so where can we go from here? What rule can we apply to make this a little bit simpler? Well, all our bases are the same. So the rules say that when we multiply indices with the same base, we add these numbers. We add the indices. So what have we got? We've got 8 minus 4 plus 1/3, which gives us 3 over 3 to the power of 4 and 1/3. We'll leave that as it is. We won't make that. We won't do anything with that fraction, that improper fraction. It's not an improper fraction. It's a mixed numeral. We won't do anything with that. It is in fact 13 over 3, but we don't need to worry about that because, having simplified the top, we now have this on the bottom. And the rules say that when we divide, all we have to do is subtract. And so the answer to this is as follows, which is, if we want to write it, the third root of 3. Right, so it's quite a process, but what I've done is I've applied essentially two or three index laws. So the first thing I wanted to do is I wanted to get everything to the same base, and I was able to do that. What it meant though was that when writing, say for instance 81 squared, I had to write 81, 3 to the power of 4 to the power of 2, which means because there's a bracket here, I multiply these and I get 3 to the power of 8. And similar processes for all of these. This was the standout one because it was in surd form. So the third root of 3 is the same as 3 to the power of 1 over 3. It's a fractional index. This is the root, this is the power. It is the third root of 3 to the power of 1. So you could write a 1 here, you could put a bracket here and write a 1 outside. Same thing. Right, okay, so we've got everything with the same base, then it's just a matter of multiplying through and tidying up. And what we get for our trouble is 8, negative 4 and 1/3, and 4 down here on the bottom. Essentially those 5s cancel, but we multiplied them out as the rules state. We can then apply one of the really simple and primary index laws, which is that we add the indices, and for our trouble we get 4 and 1/3, which we leave in that form because it's a good way in which to work with it, because we've got 3 to the power of 4 on the bottom. The index laws say that we subtract the bottom from the top to get our answer, and that's what we get, 3 to the power of 1/3. That is the third root of 3, which we can write as a surd if we wish, or we can leave in that form. That's up to you. Thank you very much for watching. That was quite an effort, wasn't it? See you next time.